Hi friends, in this video, we are going to learn about IPv6 addresses. When IPv4 was introduced in the 1970s, and accepted as the protocol for Internet, a pool of 4,294,967,296 IPv4 addresses were created. It was firmly believed that these 4 billion addresses would be sufficient to cover any future growth of the Internet. But, with an ever-expanding user base, and a growing number of IP-enabled devices on the Internet, IPv4 addresses started getting exhausted, leading to serious concerns about its scalability. So, in 2012, IPv6 was developed to meet the growing demands of new devices. IPv6 address pool has approximately 340 undecillion, or 340 trillion addresses, that is unimaginably large number. Besides large address pool, IPv6 also brings in a lot of other improvements, that makes it a lot more efficient and practical. So, let's take a dive into the basics of IPv6 addressing, by comparing it with IPv4 addressing. An IPv4 address is 32 bits in length. It contains 4 octets, and each octet has 8 bits. In IPv4 address, octets are separated by dots. Now in comparison, IPv6 address is 128 bits long, providing a massive pool of addresses. IPv4 has 4 fields called octets, whereas IPv6 has 8 fields called as words. Each word has 16 bits. IPv4 uses dots to separate octet, but IPv6 uses colons to separate words. Let's get into some more details. So, as you can see, IPv6 address uses numbers and alphabets. It is a hexadecimal address, and uses numbers from 0 to 9, and alphabets from A to F. Now, let us look into some ways to shorten this address and make it look a little simpler. The first trick is to remove the leading zeros in a field. As seen, we have 4 fields with leading zeros, and when we remove the leading zeros from the fields, our address will look like this. The next trick is to represent fields of zeros as a single zero. We have 3 fields with all zeros in our IPv6 address. So representing it with single zero will make our address look like this. And the final trick is to replace fields of successive zeros with a double colon notation. When the computer sees this address, it will see the double colon. It will find out that there are 2 missing words, and then fills in the zeros. The rule to this trick is that the double colon can only appear once in an address. For example, if we replace another word of zeros with double colon, computer will get confused, as it now sees 3 missing words, and it would not know if the address were missing 2 words of zeros from here and 1 word of zeros from there, or 1 word of zeros from here, and 2 words of zeros from there. Therefore double colon can be used only once. The 128 bits IPv6 unicast address generally uses 64 bits for the network ID and 64 bits for the interface ID. The prefix length in IPv6 address is the equivalent of the subnet mask in IPv4 address. However, rather than being expressed in 4 octets, like it is in IPv4, it is expressed as an integer between 1 through 128. The network ID is administratively assigned, but the interface ID can be manually configured, or auto-configured. As we can see, there are 3 parts of an IPv6 address. The leftmost three fields contain the global routing prefix. This 48 bits prefix identifies the organization site within the public domain. It is usually allocated to your site by an ISP or regional Internet registry. The next field is the 16-bit subnet ID, which an organization can use to create its own local subnets. A subnet ID is similar to a subnet in IPv4. The rightmost four fields contain the interface ID. These 64 bits are used to identify the interface on a link and must be unique to the link. It can be manually configured or created from MAC address, using EUI64 format. There are three types of IPv6 addresses: unicast, anycast, and multicast. Unicast addresses identify a single interface. A packet sent to a unicast address is delivered to the node identified by that address. Anycast addresses identifies a group of interfaces belonging to different nodes, that is, multiple devices share the same address. A packet sent to an anycast address is delivered to the closest member of group. Multicast addresses identifies a group of interfaces belonging to different nodes. A packet sent to a multicast address is delivered to all nodes identified by that address. IPv6 has no broadcast addresses. Every computer that's connected on network requires a globally unique IPv6 address. Configuring an IPv6 address manually requires a lot of effort and is error-prone. IPv6 makes life simple. One of the key benefits of IPv6 is its capability of stateless configuration that automatically create interface address. By implementing the EUI 64-bit extender unique identifier, a host can automatically assign itself a unique 64-bit IPv6 interface ID, without the need for manual configuration or DHCP. This is accomplished on an interface by using its unique 48-bit hexadecimal MAC address and breaking it into two halves. The 16-bit hex value, FFFE, is then inserted between these two halves to form a 64-bit address. Then the 7th bit of the first octet is inverted. In a MAC address, this bit indicates the scope of address, and has a value 0 for global scope and 1 for local scope. It will be 0 in globally unique MAC address. In EUI64 format, the meaning of this bit is opposite, so the bit is inverted to make it globally unique IPv6 address. All computers on a local LAN will automatically create the 64-bit interface ID. But for communication, they will also need the remaining 64-bit network ID. IP version 6 has a predefined network prefix, that is FE80::/10, for use on local link and LAN. Computers will use this link local prefix, and the interface ID, to automatically create its IPv6 link local address. Link local addresses can be used to reach the neighboring nodes that are attached to the same link. Routers do not forward packets using link local addresses to other links or networks. For computers to communicate beyond local LAN, they will either need IPv6 unique local address or IPv6 global unicast address. The IPv6 unique local address is like private IPv4 address used within organization. And the IPv6 global unicast address is like public IPv4 address, routable on Internet. The stateless address autoconfiguration feature of IPv6 automates configuring of IPv6 addresses on interfaces. Computer can automatically create the IPv6 address, using network prefix, advertised by the router, and combining it with the interface ID from EUI64. The router on local link keeps sending router advertisement, containing auto-configuration information, every 200 seconds. This contains the network prefix that is used by computers to build their routable IPv6 address. Computer can also send router solicitation, requesting the router to send router advertisement. Alternatively, administrators can also opt for DHCP-based IPv6 address configuration, or manual configuration. Now the computers on LAN are ready for communication with their link local addresses and routable IPv6 addresses. But for communication on Ethernet LAN, they will need MAC addresses. IPv6 does not use the ARP broadcast for MAC learning, as IPv6 does not support broadcasts. IPv6 computers use the neighbor solicitation message to request for the MAC address. The relevant host on network sends neighbor advertisement message containing its MAC address. Just like IP version 4, there are different types of IP version 6 addresses. To fully understand IPv6 addressing, it's important to have a solid understanding of IPv6 scopes and prefixes. As we can see, there are several different scopes. The global unicast address is globally unique on the Internet. The link local address is valid and should be used on a directly connected link, and routers will not forward these addresses to other links or networks. Addresses that are valid within a single site are called site local addresses. Addresses that are intended to span across multiple sites, belonging to an organization, are called organization local addresses. Okay, so let's look at some other address types. We have global unicast, which we just looked at. This is a publicly routable address, like the IP version 4 public IP address. The prefix to identify these addresses is 2000:/3. This means the first 3 bits identify a global unicast address. It will start with either 2 or a 3. A unique local address will always start with an F, followed by either C or D. Link local addresses are automatically configured IPv6 addresses that are not routable over a network. They are designed to communicate only on the link. You can identify a link local address because it has a prefix of FE80::/10. This means the link local address will always start with FE. Next is the loopback address, ::1. This is like the 127.0.0.1 address in IPv4, and is used for local testing purposes. The last is the unspecified address, represented as ::, typically used in the source address field of a packet, when an interface does not have an address, and is trying to acquire one dynamically. Now, let's compare IPv6 header with IPv4 header. The IPv4 header contains 12 fields. Following these fields is an option field, a variable length, and a padding field that is followed by the data segment. The basic IPv4 header has a size of 20 octets. The option field increases the size of IPv4 header. Of the 12 IPv4 header fields, 6 are removed in IPv6. These fields are shown in green on the screen. The Internet header length field was removed because, unlike IPv4 header, that has variable length, the IPv6 header has fixed length of 40 octets. IPv6 routers do not process fragmentation, and hence does not have the related fields. The header checksum field at the IP layer was removed because most data link layer technologies already perform checksum and error control. The option field is not present in IPv6. In IPv6, a chain of extension headers processes any additional services, like authentication, ESP, etc. Most of the other fields are unchanged. So, the 40 octets IPv6 header contains 8 fields. The version field determines if it is a IP version 4 or IP version 6 packet. The traffic class field is like TOS field of IPv4, used to mark the priority. The flow label field is used to mark individual traffic flows. The payload length field describes the length of the payload only, and not the entire packet. The next header field indicates the type of information that follows the basic IPv6 header. The hop limit specifies the maximum number of hops that an IPv6 packet can take. The source and destination address field identifies the sender and receiver's IPv6 address. The IPv4 and IPv6 devices cannot communicate with one another, unless some translation is configured to make communication happen between the two address families. Both these address families can coexist on devices. We can build a dual-stack network, with both IPv4 and IPv6 address families fully deployed, and working independently across the infrastructure. We can also tunnel one protocol over the other, which means the IPv6 packets can be encapsulated with IPv4 headers and made to traverse the IPv4 network. Similarly, IPv4 packets can be encapsulated with IPv6 headers and made to traverse the IPv6 network. Friends, that's all we have here, and thank you for watching this video.